Let us explore Python magic methods. These are special methods that enable Python classes to work with built-in functions and operators. Get ready to unlock the power of Python's special methods. Magic methods, also known as dunder methods, are special methods in Python. They are surrounded by double underscores, that is, underscore underscore, and they allow classes to emulate built-in behavior. These methods enable operator overloading, which means defining how standard operators like plus or minus behave with objects of your class. They also handle object initialization, which is setting up the object when it's created, and integrating your classes with Python's built-in functions like print or length. For example, when you define an init method, that is underscore underscore init underscore underscore, you're specifying what happens when a new object of that class is created. Similarly, when you define a string method, that is underscore underscore string underscore underscore, you're specifying what should be returned when you try to represent your object as a string. In the example code here, we see a class named person. The init method, that is underscore underscore init underscore underscore, takes name and age as input and sets them as attributes of the object. The string method, that is underscore underscore string underscore underscore, returns a formatted string containing the person's name and age. When we create a person object with the name Alice and age 30, and then print that object, the string method is automatically called to produce the output Alice 30 years old. Here are some commonly used magic methods in Python. First is init, that is underscore underscore init underscore underscore. This is the constructor method, and it initializes a new object when it's created. Next is the string method, that is underscore underscore string underscore underscore, which provides a string representation of the object. It is called by the string function and the print function. The representational method, that is underscore underscore representational underscore underscore, gives the official string representation of an object. It's used by the representational function and is helpful in debugging. Then we have the length method, that is underscore underscore length underscore underscore, which is called by the length function and returns the length of the object. Let's explore more common magic methods. The addition method, that is underscore underscore add underscore underscore, defines the behavior of the addition operator, that is the plus symbol. The equal method, that is underscore underscore eq underscore underscore, is used when you compare if two objects are equal using the equivalence operator, that is double equal symbols. The less than method, that is underscore underscore lt underscore underscore, determines if one object is less than another using the less than operator. Lastly, the get item method, that is underscore underscore get item underscore underscore, enables item access using square bracket indexing. Here, we will understand the difference between the string and representational methods. The string method, that is underscore underscore string underscore underscore, provides an informal readable representation for end users, something that's easy to understand at a glance. On the other hand, the representational method, that is underscore underscore representational underscore underscore, gives the official representation intended for developers, ideally such that you could use the representation within the eval function to recreate the object. If the string method is missing, Python will fall back to using the representational method. As a best practice, it's good to implement both methods to give a clear representation for different audiences. For instance, in the example, the string method returns a user-friendly description, while representational gives a more precise construction detail. Numeric magic methods are used to implement arithmetic operations for your classes. These methods allow you to define how operators like plus, minus, multiplication, and division work with instances of your class. Here's a rundown. The add method, that is underscore underscore add underscore underscore, corresponds to the plus operator. The subtract method, that is underscore underscore subtract underscore underscore, to the minus operator. The multiply method, that is underscore underscore multiply underscore underscore, to the multiplication operator. The true division method, that is underscore underscore true division underscore underscore, to the forward slash operator. The floor division method, that is underscore underscore floor division underscore underscore, to the double forward slash operator. The modulo method, that is underscore underscore modulo underscore underscore, to the percentage symbol operator, and the power method, that is underscore underscore power underscore underscore to the double asterisk operator. Comparison magic methods are used to define how comparison operators work for your classes. These methods allow you to specify how instances of your class are compared with each other. First, we have the equal method, that is underscore underscore eq underscore underscore, which corresponds to the double equals operator. Next, the not equal method, that is underscore underscore any underscore underscore, corresponds to the not equals operator. The less than method, that is underscore underscore lt underscore underscore, corresponds to the less than operator. Then, the less than or equal to method, that is underscore underscore le underscore underscore, corresponds to the less than or equals operator. We have the greater than method, that is underscore underscore gt underscore underscore, corresponding to the greater than operator, and lastly the greater than or equal to method, that is underscore underscore g underscore underscore, which corresponds to the greater than or equals operator. Container methods are used to make a class act like a built-in container, such as a list or a dictionary. First is the length method, that is underscore underscore length underscore underscore. It returns the length of the container and is called when you use the length function on your object. Next is the get item method, that is underscore underscore get item underscore underscore, which allows you to access items using square bracket notation. The set item method, that is underscore underscore set item underscore underscore, allows you to set items using square bracket notation. The delete item method, that is underscore underscore delete item underscore underscore, allows you to delete items using the delete statement. The contains method, that is underscore underscore contains underscore underscore, checks if an item is present in the container using the in operator. Finally, the iterator method, that is underscore underscore iterator underscore underscore, enables your object to be iterable, meaning you can use it in a for loop. Context managers in Python use the with statement to automate setup and cleanup actions. They're controlled by two magic methods. The enter method, that is underscore underscore enter underscore underscore, which is called when entering the with block, and the exit method, that is underscore underscore exit underscore underscore, which is always called when exiting the with block, whether an exception occurs or not. Common uses of context managers include resource management, like dealing with files or database connections, exception handling, and ensuring automatic cleanup. When working with magic methods, keep these best practices in mind. First, follow the expected behavior. Implement methods in a way that matches how users would expect the corresponding operations to work. Second, return not implemented appropriately. If an operation isn't supported for the given types, return not implemented rather than raising a type error. This allows Python to try other methods. Third, keep methods focused. Each magic method should do one thing well and avoid side effects unrelated to the operation it implements. Fourth, implement related methods together. If you're implementing equivalence, consider implementing not equals as well. If you implement less than, consider implementing greater than, less than or equals, and greater than or equals to maintain consistency. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.